All right, guys. So as I was saying, we actually started our first steps in data visualization in R, and with R you can do some very impressive stuff. However, we're not really going to go too advanced. I'm going to teach you the basics that you can use to learn the more advanced things on your own. And as always, if you have questions, go ahead and ask me, in the future, if maybe you want to do something specific. But one thing that is really important too is to be able to, look for your answers on the internet. Even today, guys, I am always on the internet looking for ways to do things, even in visualization or in manipulation. It's important, it's impossible to know everything. So, doing your own research, is important. However, you will not be able to do your own research if you don't have the basics, right? So I am giving you the basics, and we're going a little further. Yeah, Romina, baby is actually teaching too. Yeah. So you will not be able to do your own research if you don't have the basics, and having the basics allows you to understand whatever you want to research, anyways. So guys, the script is already open, and I sent you the live code link so that you will be able to follow with me. Okay, so I am going to go ahead and load all the packages and all the data sets as always. Okay, now last week we did something pretty simple, but it was already cool. And by the way, congratulations to you guys. Those of you who posted some visualizations in the on the Slack channel. That was really great. It's really important to apply what you learn. It's really important to apply in different contexts. So that's really good. Today we're going to learn some more advanced things, and I would really love for you to make your own visualizations after that too. Ask your own questions. We have a lot of data sets right here. Ask your own questions and go ahead and make a visualization to that will kind of speak to the questions that you ask. All right, so we wanted to find out, wanted to compare the number of departures, across airports. So the first thing that we did was we created a data set, that had data on how many departures there were in each airport, and we kind of visualized it. So this is the bare bone, very simple bar chart using geom-call as a geometry, right? And very quickly, when you use the Ggplot function, the first argument is the data, and then you can add the mapping right in the Ggplot, okay? And then after that, using the plus operator, you can then specify how you want the data to be presented, okay? Over here, we did something slightly different. We specified the data inside Ggplot, but the mapping was inside geom-call instead. So it's actually very possible to do that as well. But then we went a little further. We added some labels, okay? Label on the x-axis, label on the y-axis, a title, a subtitle, and a caption, okay? And we even added a theme, okay? Actually, as I told you last time, the default Ggplot theme is not really, in my opinion at least, it's not really the best. Oh, for some reason, I am actually zooming. That's weird. I just clicked on the zoom button. I can actually see the zoom. Like I'm dragging it right now, but it's not showing on the stream. I think is something missing or something. I'm not really sure. I don't know. Okay. I'm not sure what's happening. Let me see. Let me try again. Okay. For some reason, it's not showing on the stream. Okay. Anyways, so the default background is not necessarily the best. So I personally like to change it. Now, theme classic was the last one that I put there, but my personal favorite is theme black and white actually, and that's the theme for the background, and then the box around the plot. But that does not mean that you cannot add color, to the data that you're representing. It doesn't mean that everything is going to be black and white, as you'll see in a second. We also learned how to save a plot. Okay, so whatever plot you make, you can save it. There's actually a second way to save it, which I don't really recommend if you're doing some serious work, and that's what I'm going to show you right now. But here, we basically try to visualize monthly average temperatures. We actually didn't do much with it. We came back to the first plot to learn about, labels and things like that. Okay, so what's the second way to save your plot? You see, when you run the code for a Ggplot and it shows up here, there's this button here, export, okay, which you can click on. So exporting means that you're trying to save to disk. Now there are three things that you can do. You can save as an image, and that's what the ggsave function does. You can save as a PDF. So if you decide to save as a PDF, then your plot is just going to show as a PDF basically. Okay, or you can copy to Clipboard. The Clipboard is that place in your computer's memory. Whenever you save, or like whenever you copy and paste, whatever you copy, okay, is saved on your clipboard, and then you can paste it from there. So in this sense, it is actually very possible to kind of copy this plot and then paste it maybe in a Word document or somewhere else. Okay, yeah. Even though I don't really recommend that as well, we're going to learn about reporting right after this. Okay, so what you would want to do most of the time is to save as image. Okay. And when you do save as image, it's going to show up here. I'm not sure. Yeah, okay. So, yeah, it was rendering basically. Okay. Now, the thing about this is you can actually resize it. Okay, if you know exactly the dimensions that you want for your plot, you can write the dimensions here, width and height. And this is in pixels. Okay, that's the unit of measurement used here. Okay. And you can change. You can choose the format. PNG. That's what we used. You can choose JPEG, TIFF, BMP. And so on and so forth. You can do that. And this is the name, and this is the directory where you want your plot to be saved. And this will be the name of the plot. For example, the name that we gave was origin departure count. All right. So you can actually write it here, and it's going to save it as that. Now, if you don't want to specify the measures here, the dimensions of your plot, you can actually resize like that. Okay, when it's too big, it will still save it as big as what you're specifying, even though you can't see it on the screen. It's still going to save it like that. Okay, so this is something that you may want to do as well. I don't recommend it for a very important reason. Which is something that I briefly mentioned a few times, and that's the issue of reproducibility. One of the great advantages of writing code is whatever everything that you have done is kind of recorded in the code itself. So there's a traceability. It's actually possible for you to know how you've moved from point A to point B using code. It's like a logical workflow, right? But when you do something manually like this, there's no way to record how this was done. But when you put everything that you need here in your code, then someone else looking at the code will see exactly how you went about it and why you got the results that you got. And you may not remember it. Let me look at the ggsave function using the question mark. The Ggplot function also has the width and height arguments, which we talked about last time, and you can specify the units here. Okay. All right. So if you want a specific dimension for your plot, it's better to put it in the Ggplot and then specify exactly where you want it, and so on and so forth. This is good practice for science. Okay, last thing that I'm going to remind you of here is that a great thing about Ggplot 2 is it's actually possible to save your plot in a variable like we did here. We called it P, and then when you run P, whatever you saved in it, which is a plot in this case, is going to show up. Okay, so that's nice. In the monthly average temperatures, the new thing that we learned was actually geom_line, which is how you plot line charts, and we said that line charts are actually good. Sorry, when you're trying to look at and the evolution of a variable over time, and a bar plot is good for comparison. Okay, if you're trying to compare things. Even though the truth is a bar plot would actually have worked here, because if you're looking at temperatures for each month, okay, it might be a way for you to compare the temperature every month. Okay, maybe you want to compare, so it wouldn't hurt to use a bar plot here, and we can actually do that. So let me just not Ggplot, geom. And that's what I really love about this. It's kind of modular, right? So instead of rewriting code, I just changed geom_line with geom_call, right? Now this is actually going to be ignored because there's nothing here that connects this code to geom_line, so I can actually run it without any problem. But just for you guys to know what I'm doing, let me just go ahead and highlight it for you. See? So with that small thing that I changed, there it is. Okay, there it is. So you can see how the temperature evolved over time. Okay. All right. Now I told you, last time we had this issue with having decimals here, and I was kind of getting mixed up. But let me show you the code if you have a problem like that. Now let me remind you, the reason why we have the decimals is because in the monthly temp data set, the month column is it's a series of numbers. So this is called a continuous variable. Okay, it's continuous, right? So when R plots it, because R thinks it's continuous, even though you have your own interpretation of it, okay, one is for January, two is for February, okay, R will plot it in a continuous way, all right? But we can specify, we can tell R, no, we don't want you to plot it in a continuous way. We want you to plot these specific values, and I'm going to show you in a second. But Leonard is asking a question. While using ggSave code, does it replace the existing plot, or we have to specify that if we were to rerun the code? If you rerun the code, it's going to replace the existing plot that you made earlier. But if you didn't change anything in your plotting code, then there's nothing to worry about. Okay. If you want to create a new plot, then you need to write a new file, because this here actually refers to a specific file on your computer. So if you're using the same path, it's going to replace it. Okay. Now, if you don't want to use the code anymore and you don't want to delete it or erase it, you can just comment it out. If you forgot the, remember the shortcut that I showed you is Control-Shift-C, okay, or Command-Shift-C if you're on a Mac. Okay, but our computers today are very powerful. So for an easy plot like this, it's going to make it. It's going to save it. It's not going to take a second. So rerunning it is really not a problem. And actually, I can show you what I'm talking about. So right now, let me use this. Okay, so all right, May 26th, right? I'm not sure you can see it, but it's May 26th on the date. And let me run this again. All right, so it's done saving now, right? Oh, okay. Okay, I think the properties are going to show me today's date, maybe last. Okay, modified today, May 30th. So the first time it was created was May 26th, but it was modified today. So it's 2:20 where I live right now. Okay, so you can see that. So this actually worked. Okay, you're very welcome. Okay, so let me go back to this. And last time I asked you, I showed the scale x discrete, but that was not really true. We're supposed to use scale x continuous. So I added a plus here. And because it is a continuous variable, okay, because it is a continuous variable, we need to use scale x continuous. Okay, it's on the x-axis and it's continuous. And inside this variable, sorry, inside this function, we can add the labels argument and say that we want the sequence between 1 and 12. Okay, we want the sequence between 1 and 12. And when we run this, our breaks and levels are different. Oh no, not again. Not again. Oops, baby is not happy right now. I think it's breaks, I'm sorry. It's actually breaks and not labels. Okay, so there we are. Breaks. So you're telling your computer where exactly you want the ticks. You know, these here are called ticks. So you're telling R where you want the ticks to be. Okay, and this is breaks. Now, if you want to change the what is written there, is actually very possible, and that's where you specify label. Okay, so the breaks, these are inside the actual data set, so you can use them, okay, because they are inside the data set. But the labels is how you want to present it, okay. So that's basically how to use it. And you know, let's go ahead and do that actually. When you install R, inside R, there's R comes with some data, okay. It comes pre-packaged with some data, and there's one variable inside R which tells you the names of all 12 months, and it's called month.ab. So for abbreviation. So if you try to run it in your console, you see that these are all the 12 months. All right. So we here, you know, for breaks, we told R that we want the breaks 1 through 12 in a sequence, but we can apply these labels. Okay, we can apply month.ab as a label. And when you do, look at that. I'm trying to zoom again, and for some reason the zoom is not showing up. That's really weird. Okay, but you know, in the small thing here, I can see the zoom, but I'm looking at the stream and I'm not seeing it show up in the stream. I don't know why. But I think you can see January, February, March, and so on and so forth there. Okay, so that's something that you can do too. Okay, all right, let's make some other plots, and let's learn some other things using the new plots that we're going to make. Okay, there's a new geom first that I want to show you. Okay, and let's look at the weather data set. Okay, let's look at the weather data set. Yeah, we have a lot of data here. We may want to filter it and focus on maybe EWR only. Okay, but I'm going to teach you what is called a scatterplot. A scatterplot. A scatterplot is essentially a type of visualization which shows you the relationship between two variables. Okay, that's not the only way to use a scatterplot. Okay, but very often it is used to determine the relationship between two variables or the distribution of a variable. Okay, when I say distribution, of course, it's a statistical term, but don't worry too much about it. We are going to explain this at some point. All right, so so what we're going to do here is, you see, we have humidity, and okay, let's do wind speed and temperature. Okay, let's see if there's some kind of correlation between wind speed and temperature. And what I mean by that is, okay, when the wind is very fast, okay, when we have really fast wind, okay, does it mean that when we have is fast wind associated with high temperature maybe, or low temperature? Okay, or is low wind speed associated with high temperature or low temperature? Okay, so that's what we want to find out. I'm not really explaining it well, but basically what we want to find out is, so let's talk about fast wind again. Okay, so if for example, I live in New York City and you call me and you ask, okay, what's the wind speed right now? And I tell you, well, the wind is very fast. Will you be able to deduce from that it's also cold because fast wind speed and the cold are always together, okay, always happen together, or fast wind speed and being hot, okay, always happen together, you know, something like that. But if you did not understand this explanation, hopefully when we do this, it's going to make sense to you. Okay, maybe we can plot all this. Oh no, let's plot everything so that I'll teach you the alpha property as well. Okay, so we're going to use the entire weather data set. Okay, so data, weather, you know, okay. Well, let's add the mapping in geo point. Okay, this is for the points there. All right, and the mapping is going to be in the aesthetics function on the x-axis. Okay, let's put temperature on the x-axis, and let's put wind speed on the y-axis, like this. All right, so I'm going to go ahead and run this first. I knew it. I should have decreased it a little. Okay, so anyways, this is the plot right now. Yeah, my baby is not happy, guys. So sorry for, you know, you being taught by the father and the son as well. Or the son is bringing a little bit of hype to whatever I'm teaching. Okay, so you see, this is what's happening here. This over here is what we call an outlier. Okay, an outlier. An outlier is, you know, an observation of your data which is very different from everything else. Let's move on. I was talking about what an outlier is, and I've said that an outlier is a representation of your data which is very different from everything else. Okay, now it will not really help us a lot to use this, you know, visualization to introduce you guys to Scatterplots, because it's like you can see that these are a bunch of points here. So let's do some filtering, and actually I'm going to show you a way that you can use Ggplot, you know, if you want to quickly look at something. Okay, weather. Let's filter by, you know, let's focus on EWR. Okay, and let's also focus on the month of January, you know. So this is, you know, 742 variables. I think that's much better. Okay, and later on, you know, we can definitely go back to this. But you see, remember what the pipe operator does. When I taught you the pipe operator, I told you that everything that comes before the pipe operator goes into the next function as the first argument, right? And you can see that the first argument of Ggplot is actually the data. And that data that you're specifying here, you want it to be everything before that, right? So there's actually no problem using the pipe operator like that. You can actually pipe your data straight into Ggplot like this. Okay, so once again, everything before the pipe is actually going to go inside Ggplot as the first argument. All right, so this is actually going to work perfectly. All right, so let's do this and let's see. We're going to have, all right, so that's it now. All right, so we can see a bunch of points here, and I wish the zoom worked. I really wish the zoom worked. Okay, guys, let me go ahead and let me restart my RStudio. Maybe it's going to I don't know. Maybe it's going to sort out the issue. I mean, okay. All right. Oh yeah, I was doing live coding. Okay, I think okay, yeah. There's something. Okay, I understand why it wasn't working now. It is going to work. Let me just run everything. Okay, so yeah. So now I understand. So this is what the Scatterplot looks like here. Okay, so every point that you see is a combination of temperature and the corresponding wind speed. Okay, let me go ahead and do it right here in the console for you to see. Temp, wind speed. like this. So this here, this temperature and that corresponding wind speed is represented by one point on this chart. Even though I don't really know where that point is, it's going to scale down in a second. I don't really know where that point is exactly located, but each point is, you know, a combination of a value in temperature and another value in wind speed. All right. So this 39 and 8.06. Yeah, so it's 39, right? 39 would be so yeah, it's somewhere here, but I'm not really sure where that is exactly. Okay, that's what a scatter plot is, and that's a very very useful visualization. So how do we interpret this? The question was, you know, are wind speeds and temperature kind of correlated in the sense that do we have some kind of pattern? So the higher the temperature, okay, or when it's very hot, does it mean that the wind is also, you know, blowing fast? Or maybe does it mean that the wind is also blowing slow? And you can see that based on this scatter plot, you lost the live code access. That's true because I restarted RStudio. Alright, so I was talking about the interpretation of this. Now let's look at low temperatures. Okay, for low temperatures, we, you know, basically have a big array of wind speeds. Okay, so for low temperature you have, you know, low wind speed, and for the low temperature you also have high wind speed. Okay, relatively high anyways. And when the temperature is high, we also have that big, you know, difference, you know, in wind speeds. You know, 60 is on average a higher temperature, okay? But with that, we have a high wind speed and we have a low wind speed as well, okay? And in the middle, same. When the temperature is, you know, in the 40s or something like that, high wind speed, low wind speed, okay? So there's really no visible association between temperatures and wind speed. Okay, so that's one example, and we are actually going to look at another example of a scatter plot later. Now there are a few features that I would like to show you. You know, it's very possible to change some properties of these plots, and that's what I want to do now. But I just wanted to show the geom points very quickly. Now, I also want to add that it is very possible to add many geoms in the same plot. Okay, now I'm going to go back to this. So I told you that, you know, this is the average temperature over time in the New York City area, and the average monthly temperature. And I told you that, you know, a line chart is possible to use and a bar chart is possible to use. Okay. If you're trying to use both, then just add both then, you know, like this. And let me add the plus to connect everything. Alright, so let me run this. And when I run it, sure enough, both geoms are shown. Okay, so the geom line is first, and that's why you see, because geom line is first, it's behind the geom call, as you can see. Okay, so the position matters as well. So if you want your plot to be very clear, then make sure that you know, you respect the order of your geoms. But of course, changing colors or transparency, which is something I'm going to show you right now, is also important. So I just wanted to show you that you can add as many geoms as you need to your data. Alright, so just because I'm teaching, let me change the order. But I think the colors are the same, right? So it's going to be okay. Yeah, they're not really the same. One is dark gray, I think, and the other one is black. So we can see the two geoms here, you know, and it's actually very interesting, and that you can do it in a modularized way. Okay, now going back to our geom point here, you know, so you see this is not really too much of a problem, but let's focus on January and February so that we have a lot more data. Because I want two values, I'm going to use the in operator. Okay, so I want January data and February data. All right, so that outlier is coming. So, you know, it basically destroys everything. We're not going to talk about it, at least in this introduction, but dealing with outliers is a very important skill to have if you're trying to do some modeling, because outliers, as you can see here, they actually distort a lot of your results. So it's actually good. It's important to understand how to deal with them. Okay, dealing with outliers and dealing with missing data are two very important skills that you need to learn if you are into modeling. Okay, or else your results might actually be distorted by their presence. Okay, so let me not put February because this is, remember Romina showed us an article. This is where we had I think a tornado or something like that. So the wind speed was very high, you know, over 1,000 miles per hour. That's really insane. So let's do January and March. Okay, so that we can see what the distribution looks like. All right, we're going to add April to it to have a lot more data. Okay, so good. Now you can see that there's a lot of clustering. Okay, a lot of points are, you know, put together, and when that happens, this might actually be a little problematic. Okay, it might be a little problematic in the sense that you might not be able to, you know, visualize your data well because of these cluster points. Now, in a case like that, there are a few things that you can do, especially if you're using the Scatterplot. For example, you may decide to make the points smaller. That's one thing that you may want to do. All right, so inside the geom point, it's not going to be in the mapping. It's not going to be inside the AES function. So notice that I'm now outside the AES function. That's where I put the comma, okay, because I'm outside the AES function. And you can put size, okay. Let's try size equals 1. Okay, so you see the points are a little smaller, and you don't see the cluster, you know, those big clustered points anymore. You can't see them anymore. But we have some small clusters here. Okay, so you may want to change it to 0.8 maybe. Okay, even smaller. Hey, you know, this is something that you might want to do. Who knows? You might want to do them if you don't want the points to touch each other. Okay, but something else that you may want to do is, instead of using the size argument, and actually the size argument works for, and not for geom point only, it works for geom line, because it's going to make the line thicker or thinner. We'll try it out after this. Okay, but one thing that you may want to use is alpha. Alpha is the level of transparency, where 0 is completely transparent. So let me use alpha 0. You won't see anything because all the points are there, but they are completely transparent. And 1 means that they are completely opaque. So it's 1 by default. So you can see through them. So that's what completely opaque means. Okay, so if you have high points of cluster, it might actually help to make them a little transparent. Let me go down to 0.5. Okay, so you see now you can identify the points of clusters much easier. Okay, because the points are, so wherever you see the dark colors, this is where they're transparent. By the way, Romina actually posted a plot, you know, in a field of study where she used the alpha arguments. All right. Now, I might not be satisfied with 0.5 because of how it looks, you know. Let me actually go down to 0.4. Okay, maybe not. All right, so I think that I'm going to really take drastic steps and go to 0.1. Well, I think that this is actually a little too much. Maybe 2.2 is going to be okay, or 0.25 or something like that. Okay, let me try 0.3. Okay, maybe this is what I like. And I can identify the highest points of clusters. Okay, we have a high density of clusters here. You know, and you might actually bring, I mean, there could be an interpretation for this, even though we're not going to give an interpretation for this plot at least. I realized that I never wrote a comment here. You can see, is there any association between temperature and wind speed? Okay, so I may ask the question, is there any association between temperature and wind speed? Okay, all right. So we just looked at the size argument, and maybe it will be better. Okay, various graphic properties. All right, so we just looked at size, and we also looked at alpha. Okay. All right, so let's actually answer some questions, and then you know, look at the new properties with some new visualizations here. Flights. This is our extended flights data. Now, something kind of fun. Okay, let's say that you want to find out if pilots, okay, tend to fly faster if they are going further. Like if their destination is further, you want to find out if on average they fly faster. Okay, or the distance doesn't matter, they will just fly the normal speed or something like that, whatever what the distance of the destination is. All right, so let's add it. Okay, do pilots fly faster for longer trips? I think it would be better to say over longer trips. Okay, so two things we need here. We need distance and we need average speed. All right, so a scatter plot is a very good visualization for something like that. So remember that if you want to find out the relationship between two variables, a scatter plot is something that you may want to use. All right, so we're going to use the flights data set. Yeah, okay, so we already have average speed and we also have distance. Okay, it doesn't matter whether it's kilometers or miles, it's the distance anyways. But if I'm using the distance in miles, the average speed in miles per hour, it would make sense to use the distance in miles as well. Or if I use the average speed in kilometers per hour, it would make sense to use the distance in kilometers. Okay. All right, so let's pipe flight straight into Ggplot. Okay. And okay, this time around, just so that we can, you know, switch things up a little bit, let me put the mapping inside Ggplot instead of putting it inside the geom. So on the x-axis, now I don't really understand the theory, you know, behind, you know, climate stuff or wind temperature and stuff like that, and you know, wind speed and temperature. But the choice, when you're trying to look at the relationship between two variables, the choice of x and of y is very important, you know, because there's what we call the dependent variable and the independent variable. What does it mean? You want to find what variable affects the other variable. In other words, what variable is affected by the other variable. Okay, so the question here is, do pilots fly faster over longer trips? So what is affected here is the speed, presumably. Okay, is the speed, and what affects is the distance. So you want to know if distance has an impact on speed. All right, so the variable which is affected is called the dependent. It depends on something else. Okay, it's the dependent variable. So the dependent variable, you always put it on the y-axis, and the independent variable, okay, in this case distance, would be on the x-axis. Okay, so it's really important to remember that, and that's when you're trying to look at, you know, the relationship between variables. So average speed miles per hour, all right, because distance is by default in miles. All right, let's take a quick look at this. Oh, all 300,000. Oops. Oh, Ggplot. I haven't actually specified any geom, right? So it's going to be geom points. But guys, we need to do something here. We need to kind of filter it a little bit. Geom point, because we have 300,000 or so points, and for those of you whose computer is a little slow, this is actually going to, you know, kind of stop everything on your computer. So let's do a little bit of filtering. What can we filter right here? Let's say, you know, maybe, you know, we have more flights in the summer months. Let's just focus on the summer months. Month in. Okay, let's do the sequence between, let's say, May, okay, and the 8th month, August. And let's connect with a pipe like this. This is still a lot, you know, this is still a lot. You see, even on my computer, I have a pretty fast computer, guys. Check what is happening even on my computer. Okay, maybe, you know, maybe you should hold on a little. Let's filter a little more. Okay, you see what's happening. So we have a bunch of points. I don't really know. Let me run this only to see how many points you can see here now. Yeah, you see that we have over 100,000 points. You know, guys, if you want to filter more, please be my guest. Go ahead and filter more. Oh, you know, let's do it together. Let's do it together. Maybe we could focus on less months. Okay, let's say. Let's focus on 2 months only. So May and June. May and June. See. Alright, so we have less data, but it's still a lot. And your computer is still trying to plot it. How many values do we have here? We have 50 or so thousand. Okay, guys, you know what? Let's just do May. It's still going to take a bit of time, but nearly not as much time. Okay, I think this is enough data for what we want to show. And I don't know if you realize the shape has not really changed much. Okay. All right. Okay, so again, there's a lot of overlap, so it makes sense that you may want to make them a little transparent. Again, I'm going to get out of the AES. So you see, this is Ggplot. If you specify the alpha here, it's going to affect everything. But I just want to use it on the points. Maybe I'm going to add other things to it, so I don't really need to do that. Alright, so let's do alpha. I think we did alpha 0.3 last time. Is 0.3 going to work here? Because it's not the same number of points, right? So it might be okay or not. You see, it's not even working that much because there's so much. The clusters are so dense. Okay, so it's a little difficult. Let's do 0.1. You see, even with 0.1, you see these clusters, guys? Wow. Okay, 0.05. So this is almost completely transparent. You see very big clusters here. In any case, doing this is really not going to help much, as you can see, unless you make your points completely transparent. And then you don't really have a plot at this point. So alpha here is not really going to work, to be honest. But, you know, let me just maybe leave it at 0.3 again, even though it's not really going to help much. But the most important thing that I want to show you guys here is the association between distance and the speed. So what can we say? Okay. Now, for short trips, you know, because this is the distance axis. Oh, I can zoom here. And it's going to take a bit of time. All right. So for short trips, here, you see that overall you have, you know, a lower average speed. But what happens to that average speed as the distance, you know, increases? As the distance increases, okay, you see that there's this increasing trend, okay. So it's as if pilots indeed tend to fly faster when they are going to places that are further, okay. You see that increasing trend. Average speed goes up on average, okay, as the distance goes up. Now, of course, these outliers here, this is Hawaii, of course, because Hawaii is the only place that is about 5,000 miles from New York City, okay, where planes still go and it's still considered a domestic flight. Okay. So that's basically an association. There's a positive relationship. So if someone told you, can you please verify if our pilots are flying faster when they are flying over longer distances? And the answer is yes. And we were able to show it using this plot. Of course, you can use econometrics. All right, so I was saying that we can use econometrics to have or to try to obtain statistical evidence that there's a positive relationship between distance and the distance of a trip and the average speed of that trip. We can find statistical evidence for it. But looking at this plot, we are pretty sure that if we use statistics, this is the evidence that we're going to find. Okay, so visualizing your data is really important. Now, one thing that I would like to add to this is, as you can see, you know, distance over here, we are in the thousands. You know, it goes to, you know, all the way to 5,000. And for average speed, you see the scales are not the same, basically. The scales are not the same. So very often when you're trying to visualize data like this and the variables, okay, that you use to find association, when the scales are not the same, you know, one variable is in the dozens and the other one is in the tens of thousands, and you still want to find if there's association, what you want to do for that is to, you know, you want to scale them using the log transformation, okay, logarithm, okay, or a logarithmic transformation. So this is actually going to scale your data so that the data is kind of comparable in a way. So of course there are ways to do that. I can go to my data pre-processing step and mutate, and I can log distance and then log average speed, miles per hour. I can do that and then plot the log data, okay, after manipulating it, okay. But Ggplot 2 has some really nice functions for that, okay. So I can add plus scale x log 10. Oh, not long, but log 10. This is to scale distance because distance is on the x-axis, and we've got scale y log 10. Okay, this is going to scale the y-axis. It's going to take the log, okay, so that they are kind of together and they are comparable. Now, when we do that, you will see that it will be slightly easier for us to see that positive relationship between the two variables. Okay, so you see that relationship, you can see it's kind of a linear relationship now. Let me zoom so that we can see the data better. Okay, yeah. So you see that for increasing distances, we definitely have higher speed on average. Okay, and one thing too is when you use scale x log 10 or scale y log 10, the labels here do not change. So you still have the data, or the original data, but what is plotted, okay, is the scales data. All right. So you can still kind of use it to make some sort of inference. Right, so I just wanted to show you another use case for GeoPoint, and also these two functions. But again, we are also trying to use some learn some properties. Okay, so we looked at size and all that. All right, now yeah, again, guys, I'm sorry I'm really all over the place, but I would like us to go back to our line chart here. Actually, this time around I'm going to remove the log. I just commented it out. Alright, so let's take a quick look at it. Alright, so there are ways to change the line type. Okay, there are ways to change the line type. And if you want to change the line type, okay, so inside the geom line here, okay, you can add line type like this. And there are many line types. In order to access them, you use a number. So number 2, for example, is this. Okay, so that is the dashed line. Okay, so that's another property right there. It's a dashed line. Let's try number 3, line type. Alright, so it's a dotted line now. Okay, so it's dotted now. And actually, let me add size, because I told you, right, that I was going to use size here. Let's do size 2. Alright, so you see, now these little shapes there, oh, I thought they were dots, you know, so it took me, oh, no, okay, no, that's number 3 now, okay, that's number 3 now. So you see the size actually makes it bigger. This is a combination of line type and size, you know. You see the number 4, this is what it does. Okay. But you can actually find a whole list of everything on the internet. Let me try to find it for you. Line types in R. You can basically Google it, and then you will have some articles that will show you a list of the different line types that you can get access to. Alright, so there it is, for example. Alright, so blank, solid. So by default it's 1, dash, dotted, dot, dash, long dash, 2 dash. Okay, so you have that. But there's another property too. Actually, the various graphic properties, I think I'm going to put them on top since we're now using everything. Okay, I'm going to put it right here. And I'm going to make a section out of it. Alright, so we just talked about line type for you guys. Alright. I just wanted to show you that. Now, back to geom point. Yeah, guys, I'm really sorry I'm all over the place right now. Okay, no, this is the geom point that I want here. Okay, back to geom point. You also have the shape argument. Okay. So a geom point is a dot, you know, but shape will change, well, the shape, right? So let's try shape 2. You know, it would have been better if it was suddenly smaller, so that it wouldn't, you know, take all this time to reload, which we had a smaller data set. Of course, we can filter and take the very small data sets. Oh, why is it not even showing anything? Is this the, okay, so there it is. You see that shape there? And guys, if your computer is slow, I really recommend don't run this code. Just follow, and if you really want to do it, just do it maybe after this, because it's really going to block you from working. You know, maybe after the class today, go ahead and try it. You see, it's even taking more time here. Anyways, hopefully you can see that these are little triangles, and there are a bunch of shapes. Okay, point shapes in R. Okay, so these are the shapes right here. You see, so you have 1, 2, 3, 4, 5, and then you have everything else. Okay, and I just googled for you know, point shapes or plotting symbols, as you can see here, plotting symbols in R. Okay, all right. Okay. Now, guys, we are going to talk about aesthetic mapping. But again, you know, there are many things like that you can kind of use to get exactly what you want, or how you want to represent your data. Okay, I'm taking a quick look at the chat, and we do not have any new question. Okay. All right, so guys, let's talk about what we call aesthetic mapping. Okay, this is a very powerful concept in very powerful concept in Ggplot, which kind of really makes your work easier, okay, if your data is in the right format. What am I doing right there? Okay. Now, this is what we're going to do. Let's create a data set. Okay. And we want to find out what the average departure delay for each carrier is. Okay, average departure delay for each carrier. Now we have, I think, 15 carriers. Let's just focus on the three carriers that are the most popular. Okay, visualize average departure delay for each carrier. Okay, now I'm saying average, we can do it monthly. Okay. Alright, so we'll need to do some data manipulation first. We'll use flights. And because we want to do some averages, we need to group by first month. And we'll group by carrier. Okay, because with monthly, average departure delay. Yeah, guys, we are having the same problems again today. I am really not sure what's happening. I thought that we were really over all these issues, but apparently we're not. Really sorry about that, guys. Please let me know if you are back. Say something in the chat, please, if you are back, and then we'll just continue. Okay, great. Thank you very much, Romina. Okay, so we are trying to visualize monthly average departure delays for each carrier. So we had to group by month and carrier. Okay, and then compute the mean there. So average departure delay, mean, DEP delay, and we remove all NA values. Okay, so this is what we get right there. Again, I can save this. Okay, all right, Jody, welcome back. I can save this into a variable and then plot it. Okay, but let me just go ahead and pipe it directly into a Ggplot. All right. Now the thing here is, we would want. Okay, let's try to do this first because I want to show you how powerful this thing here is. Let's do the mapping in Ggplot. Okay, so on the x-axis, of course, we're going to put the month there, and on the y-axis, we're going to have the average departure delay. Okay, and how do we want to represent it? We can represent it with a line chart, because maybe you want to see the evolution over time. Maybe you may want to visualize it to as a bar plot. Okay, because maybe you want to compare month by month. But let's try the line chart first. Okay, let's try the line chart, and you'll see how messy the result is going to be. Yeah, this is much smaller data, so it's not going to take much time. Okay, all right, this is really messy data, a messy visualization, I wanted to say, because the reason why you see something like that, okay, is you see for number one you have many values. So for month one here, okay, you have this value. On the same month you have this other value. On the same month we have that other value, and so on and so forth, right? So for one you have many values, so it's actually going to give you it's going to put a dot where all the values are right above the value 1, which is for January, basically. Same for 2, same for 3, same for 4, and so on and so forth. Okay, so in cases like that, that's not really ideal. Okay, so remember last time we used the group function. Okay, this is something that you may want to use here as well. Now this time around is the thing about this is, even though for 1 you have this value for the month of January, and for 1 you have this value, the two values are not supposed to be plotted together, and actually all the other subsequent values are not supposed to be plotted together. But you want the system to know that each of these values, even though they are for the same month, they are grouped by, in a way, carriers. So basically you want the plot for 1/15 to be for 9E, and then 2 whatever for 9E, 3 whatever departure delay for 9E, and so on and so forth. So you want them to be by group. So this is called an aesthetic mapping because it's not really a value that you are plotting, okay, but it is a variable that you are mapping to something, just like we did for x and y. You see, we mapped the month variable to the x-axis. We also mapped average departure delay to the y-axis. Now we want to map the carrier variable to group. And because we are doing that, we have to stay inside the aesthetics, okay? Whatever you put inside the aesthetics is a mapping. It's an aesthetic mapping. All right, so let's do group carrier. And let's see how it changes. So this is more like what you're looking for, okay? So we now have several lines, and each line represents a specific carrier. Let me zoom, okay? Each line here represents a specific carrier because they have all been plotted by group, okay? Very important here. But again, everything is black. There's no legend, you know, so it's not really the best thing in this case, at least. So we just looked at group, so let me just add it here. Okay, now the best way, in my opinion, that you would plot this is to group by, sorry, not to do an aesthetic mapping on group, but an aesthetic mapping on carrier instead. Oh, sorry, color. What am I doing? Okay. All right, so why is this an aesthetic mapping? Actually, before doing this, guys, we had group, so let me just leave group. I'm going to copy and paste so that, you know, we don't lose this code. All right, so I'm going to remove this. Now, if I were outside AES, the aesthetic mapping, and I said red, for example, okay. Ooh, what is going on? Why is this not red? Oh, I'm doing it in Ggplot. Okay. Well, if I do it in Ggplot, it's not going to work. I want the lines to be red, so I have to specify red in geom_line. Okay, my bad. Because it's the lines that I want red, right? Okay. So there it is. Everything becomes red. Okay. Or if I specify blue, okay, everything becomes blue. Okay. By the way, there's an R function called colors, okay, as a function, and it basically tells you all the color names that you can specify here, all of them. Okay, is the colors function. All right, and there are ways to kind of see what colors these are in the scales package. I can show that to you later. Okay. So so this is just like putting paint on what you are plotting. But aesthetic mapping is not putting paint on what you are plotting. It is more, it's basically more, it's smarter than this. So let's now put it in the AES, because everything you put in AES in Ggplot is actually going to be applied to every geom that you use. So if I do color carrier, check what happens. All right. So putting color and the name of a variable inside AES, which is the aesthetic mapping, okay, is not just putting paint on it, but it is assigning each carrier to a specific color. That's what aesthetic mapping. So we are mapping variable to the color, okay? So each element in carrier is going to have its own color. And the nice thing here is that even a legend is created for you. Okay, and of course there are many carriers, so this is difficult to see, but I believe you get the idea, right? So you can basically look at this and know for a fact which, you know, line corresponds to which carrier. Now this right here, they have had a lot of improvements in the year, you know. It was a very rough year in terms of average departure delay. I mean, we are in the minutes there, guys. Can you imagine? Over an hour of delay, you know, in many months. But then at some point they decided to take things back in their hands and to do a good job. And you know, they started actually going early, because this is 0 here, right? So they started going early. Because maybe, I don't know, they wanted to prove that, hey, we have changed, so instead of going late, we're going early now, right? and I mean you've seen some improvement here basically, right? And overall you can see what's happening here. So that's an example of aesthetic mapping, okay? And usually you will do some aesthetic mapping with colors, but not necessarily. You can actually do some aesthetic mapping with other properties. You can do it with size actually, okay? You can do it with size. For example, let's try that. All right, so you see, visualize monthly average temperatures. Okay, so we already have the data set here. Okay, I'm going to try to visualize it again. No. What I wanted was the departures. Yeah, the counts. Yeah, this is what I wanted. Okay, so we have this right here. I'm going to make another plot basically. Okay, I'm going to make another plot. Let's say I want to visualize it with for some reason I want to visualize it with geom point. Okay, so data dep count geom line, geom point. Sorry. Okay, let me do the mapping inside geom point. I'm kind of switching it up so that you guys can see that it's really the same thing at the end of the day. If you want to put it in a geom point, in a geom, or you want to put it in Ggplot. Okay, but remember, if you put it in Ggplot, then every geom that you use is going to just assume that the aesthetic that you put in Ggplot is what they are going to use, unless you specify something else in that same geom. Okay, so AES on the x-axis origin, on the y-axis number of departures. Okay, so this is not a line, this is not a bar chart, but the reason why this point is very low is because there were fewer departures in LaGuardia, and JFK was in the middle, and more departures in Newark. Okay, but check this. Because we are inside AES, let's actually do this. Okay, all right, so besides having a point at each level here, the size of the point actually speaks to the level of the variable. Okay, so here the point is not only lower, it is also smaller. Okay, here you see it's in the middle, and this is much bigger, and you have some sort of scale here. If you have this side, and this is the level, if you have that other side, and this is the level, and so on and so forth. Now, I just did this for demonstration purposes, but this is a bad visualization, because you see there's already a way to know what the values are, because you see this is horizontally aligned with this value, so I know that this is lower than this, which is lower than that. So I don't need to add another mapping to this. Okay, this was already mapped to the y-axis, so the vertical positioning tells you what the value here is. Okay, so I didn't need to add another size mapping to it as well. Okay, so usually aesthetic mappings are used if you want to add more data to or more information to your plots. This is how you want to use your aesthetic mapping. So what do I mean by that? Let's check it out. So on the DEP count, we don't really have the other type of information that we could plot, but we can do something about it. And actually, and again, guys, I'm really all over the place. I'm really hoping that you forgive me for that. But let's just ask this question, okay? Are people flying out of Newark more because maybe there's less delay there? Okay, or no, is the choice of departures, and of course these departures is not really the number of people, it's more like the planes, the actual flights. But we can ask, do carriers prefer to fly out of these different airports based on on delays. Maybe they prefer to fly out of places where there's less delay or something like that. Let's try to find out. Okay, let's try to find out. So since we're still talking about delays here, I am actually going to do it here. Okay, so after the gg save, okay, do carriers carriers prefer to fly out of airports with less delays? Okay, so if this is true, and we're going to investigate, if this is true, then this would mean that there's less delay in Newark, a little more delay in JFK, and LaGuardia is the place with the most delay. That's what it would mean, right? But we don't know, so let's find out. So we'll need the data for it. Okay, we already have code. Okay, so that was only for the count, but okay, so flights, we're going to group by origin, because we want that summary for each airport. And for summarize, we're going to do two summaries actually. The first one is going to be number of departures, so we need it again, and this is going to be the n function because we want how many departures. And the next one is average departure delay, okay, which is the mean of departure delay, and we remove all the NAs. Okay, so let's take it. Okay, all right, so that's it. You know, so we have origin, we have the number of departures, and we have the number, the average delay there. Okay, so we're going to go ahead and pipe it directly into Ggplot. All right, I'm going to put it in the geom there. The aesthetics are going to be in the geom. Okay, so on the x-axis, check this. On the x-axis, oh no, it's not going to. Oh, okay, no, it's fine, it's fine. So on the x-axis, we have origin. On the y-axis, we have number of departures, okay? So this right here is the same plot, departures. Oh, data must be a data frame. Oh, I just did something. Okay, so I can just put it in Ggplot. What just happened? I'm not really sure what happened right now. That's what I just did, right? Did I mistakenly delete it or something? I'm not sure. Okay, so let's do geom point anyways, and on the x-axis we have, let me run it again. Oh yeah, it's right here. Origin. On the y-axis, and departures. That's what I was trying to do right now. Okay, so there it is, right here. Okay, so again, the horizontal alignment tells you how many departures, but still inside AES, we can add size, and the size is going to be by average departure delay. So you see, this is extra information that you are putting on it. This is extra information. So it's different from this useless stuff here where we had redundant information. Okay, this is a bad plot. All right, so let's run it. Okay, so we can't really say, okay, based on this that yeah, I need to zoom for you. We can't really say based on this that, okay, departure delay is the reason why there's more departures from Newark, because in terms of delays, this is actually the place with the most delay. Now, you might actually want to say, okay, then maybe that means that carriers prefer to fly out of places where there's more delay, because, okay, we know that there's delay, so even if there's a delay, no one is going to matter, they're not going to give us bad reviews and things like that. Of course, you need a more rigorous study, you know, to conclude that. But looking at this, you can't even say that as well, because see, there's the place with the the place with the least number of departures is number 2 in terms of delays. It's not like it's number 3, like the place with the least delays or something like that. but it's number 2. So you can't really say that. So there's really no correlation, no observable correlation with this. Of course, we need more rigorous studies, but just to tell you, this is a way to add more information to your plot. Okay, so you use aesthetic mappings for that. Okay, now guys, let's do this plot here. All right, so we can now remove this because we are using an aesthetic mapping with size that is the right way of doing it. Okay, now just for you guys to see, aesthetic mappings are used to add more dimensions to your data. What do I mean? This is known as an XY coordinate system. So it's a two-dimensional plane. You have the x-axis and you have the y-axis. That's 2 dimensions, right? But the size of the points adds more dimension to your data. And you can actually use colors to add more dimensions to your data. You can use shapes to add more dimensions to your data, and so on and so forth. Okay, so this is what aesthetic mapping does. You can add more dimensions. It's not just like painting or specifying, I want this shape or I want this size. If you want a specific size, then in your code, it's a repetition, I know, but size is not going to be inside AES. It's going to be outside AES. But then you will have to tell a number, and that number is going to be used to give all your points the same size. But if you want the size to be dynamic, to be related, okay, or connected to a specific variable, okay, if you want your size to be connected to a specific variable, then you have to put it inside AES and then add that variable name to it. Okay, now there's one more thing, or 2 more things actually, that I want to show you, and then we'll call it a day. And of course, I haven't really been making quality or publication quality plots. No title, no redefining of the labels. I haven't added all these things yet. Okay, because I'm just showing you the different properties and all that. And I wanted to cover aesthetic mappings today. It's a very powerful concept, as you'll see. Okay. All right, so over here, we're going to calculate the daily average departure delays. Okay. And for that, oh man, my son is not happy today at all. Daily average departure delays by origin. Okay. Actually, okay. Okay. All right. So let's do it. Let's do it. So flights this time around, because we want it by origin, and we said daily, right? So we're going to have to group by month, then day. Okay. So you have to group by these 2 values so that we can actually refer to specific days. And then because we want it by origin, we also have to group by origin. Okay, and because we want the average, we need to summarize, right? So AVG DEP delay, mean DEP delay, NA.rm equals true. Okay, so yeah, there's the data right here. So we can go ahead and plot it. Normally I wouldn't do this. I would save my data in a variable and then plot it. It's better because if you want to use the data later, you can do that, and it's actually fairly easy to do it like that. Okay. All right. So Ggplot geom. Let's do geom point again. Okay. Let's just do geom point. And for the aesthetics, I didn't write mapping, but it's going to work. Okay, it's going to work. So we have month on the x-axis. We have y. Y is going to be the average departure delay. Of course, that's the data that we're going to put there. And let's see how messy this is. Once again, for one, all the departure delays for each. Oh no, my bad. My bad. Oh. Okay, guys. So over here, there's actually something that we need to do. We can't really put month here because what we want is the daily data, right? That's cool because I'm going to teach you a new function actually. So you see there are 31 days here. So you have 31 points for one because I decided to put month here, okay? And over here we have I guess 28 or 29 days for February, and then you have 31 for March, and so on and so forth, right? So actually, you see this outlier here. This is something that I wanted to show you, but we'll talk about it. It means that in March you had a day that was really crazy in terms of delay, where the average delay was almost 2 hours on average. Can you imagine? That's really a lot. Okay, so you can't really put month on the x-axis because you're going to get a plot like that. Okay. You can't really put day as well, even if it's day that you want. Okay, you can't really put day because it's going to show you, for each day, it's going to show the average departure delay of the month. So here you have the average departure delay on the 1st of January, the average departure delay on the 1st of February, and so on and so forth. So this is not really what you want. So on the x-axis, you actually want a value that will uniquely identify each day on your data set. Okay, or each day of the year. Let me run this again. You should have 365 exactly. So you have 365 groups, but of course you have more than 365 rows because you have the same thing for each of the three origins. So this should be equal to 365 times 3. Okay, let's try it. 365 times 3. So 1095, and that's the number of rows we have. Okay, because we have it for every origin. Okay, every airport of origin. So how can we uniquely identify each of these values? It would actually help if we had. It is still grouped by month and day, which is good. Let's say if we have 1-1, okay, for example, if we have 1-1, maybe we're going to call it 1. And if we have 1-2, which is January the 2nd, we can call it 2, and so on and so forth. So for every combination of month and day, we're going to have a unique identifier, and that identifier is going to be for the day of the year. Okay, the day of the year. All right. So basically, before Ggplot, we can add a mutate there. Okay, and let's call it ID or day ID. Okay, the unique identifier, and let's call it row number. Now this is very important, guys. Remember, up to this point here, up to this point, okay, and that's the data that you see. The data is still grouped by month and day. Okay, it is still grouped by month and day. Now, that grouping is really important because it's because it's for each month and day that we want to apply this row number. If there was no grouping, okay, then applying row number was just going to put a number for each row, 1, 2, 3, all the way down to 1095. That's what would happen. Okay, but in this case, we still want to keep the groups. I'm sorry, guys. Okay, so check this. Okay, let's see. Yeah, it's row and day. So 1, 2, 3. Huh. Oh no, for all of these, I want the same 1 basically. I know there's a function for that. So okay, what's happening is that it's okay. So for this group 1, 1, 1, 1 is giving me 1, 2, 3 because there are 3 rows here. But what I want is for 1, 1, I want 1. For 1, 2, I want 2. For all the 1, 2s, I want 2, and stuff like that. I know there's a function for that. But let me check. Row. No, it's not going to be group rows. Let's see. Is it row number? So in a situation like that, this is exactly what I would do. I would go to Google and then look for it there. But I don't want to take too much time. Add row, let me see. Row delete, row patch, group walk. add row. Okay. I don't want to take too much time to look for it, but let me show you what a good solution here would be. And it seems that I deleted this. Okay, this is what a good solution for this. This is what it would be, and this is going to allow me to teach you a new function. Actually, we don't really have any in the flights data set. We don't really have any column for dates. Okay, for unique dates. And maybe that's something that would be a good idea to add. So let's actually go ahead and do this. So from the flights data set, okay, we're going to use okay, just to show you what's happening here. You don't really need to do this, but it's okay if you do it. So we're going to select these three only. We already know what the year is. Okay, let me just add the year. Okay, it's fine. Let me add the year because we're going to use a function right now. Okay, now these three values are kind of separated, right? You have one column for year, one column for month, one column for day. Sorry. But you can actually add a date variable, which does not exist in the flights data set, a date variable, a date column if you want, okay? And use the function isodate, okay? And isodate, what it does is that it uses different components to create dates. So the first argument of isodate is the year, okay? So we want the isodate function to take the year argument inside the year column, like this. And it also has another argument called month, and you want the isodate to take the month element inside the month column here, okay? And you also have date. Day, I'm sorry. So you want the isodate column to take the day element inside the day column. All right. So year here is the argument of the isodate function. By year here is the column of the flights data set. So if this was called something different, you would put it here. Okay. And same goes for month and day. So let's run it. All right. So now you see that we have a new function, a new column that uniquely identifies these days. And because it comes as a date time, it's going to add an hour to it, but that hour is not really important to us. We don't really mind. What we are interested in is the day, okay? And if we actually go down, like to February and all that, you will see that it will kind of follow it. Okay, so now we have a unique identifier. Maybe we should put it in flights extended actually, so that we can import it right away. Okay, I guess that would be a good idea. But now that we have a day column, where was I? Okay, right here. Now that we have a date column, we can now group by, instead of month and day, because the reason why we group by month and day was because we wanted that unique identifier, we can just group by date. So for each date and each origin, we are calculating the average of the departure delays, and that's what is happening here. All right, so let me go ahead and run this all the way to summarize. Lo and behold, date and origin. What's happening? I have the dates column there. Oh, yeah, I was trying to calculate departure delay here, but I didn't select it. So right now it's not in my data set. By the time I get here, it's no longer in my data set, so I can't calculate it. So let me add it now. All right, let's do this. I think. All right, so everything is grouped, and we can go ahead and summarize. Oh, class function? Oh, it's seeing it as a function. Okay, because of the date function. Okay, that's too bad. Okay, let's change the name of this. Let me just call it date with capital D. Okay, because date is the name of a function. So group by things that I'm referring to the date function and not the date column. Oh, no, my bad. The reason I was actually surprised why this was the case I didn't add a pipe operator. So because it doesn't know any column called date, it assumes that it's the date function. But now that I created the connection, it will know that I'm talking about the date column. Okay, and there it is. So right now we have date, which we can plot on the x-axis now, and it's a DTTM class, which is great because it knows that it's a date. I can plot it easily on the x-axis. And I want to plot this. You know, the day ID stuff, we don't need it anymore, so I can remove it. Okay, can remove it. All right, so let me run it again. All right, perfect. So we now have a date, we have the average departure delay, we have the origin. Wonderful. Now let me go ahead and pipe it into the Ggplot. On the x-axis, I want date. Okay, on the x-axis. And y departure delay, average departure delay. And you'll see, people, that this is what we get. All right. So these are the different departure delays. Okay. But of course, it's mixed. Everything is mixed. All origins are all together, as you can see. But this is basically what's happening here. Okay. But now, by the magic of aesthetic mappings, check what this is going to change to in a second. Okay. We are going to assign color to origin. So each point is a specific delay for a specific for a specific day, exactly. So again, each point is a specific delay for a specific day in a specific airport. All right, that's exactly what each point represents in this data set. Okay, but when we add, you know, that when we map origin to color, now everything is going to be color coded, and you will be able to see what point corresponds to what airport. Okay, so let's do that. All right, so now, you know, we can kind of look at it. So we know now that every red point is for Newark. Okay, every green point is for JFK, and every blue point is for LaGuardia. Okay, by the magic of mapping, this happened just like that, and the legend was created for you automatically. You didn't have to do anything. Okay, so if we want to know which airport has a higher average departure delay on average over time, you can basically look at the cluster of points with the same color, which is higher than other clusters. Okay, so there are many points, guys, so it's kind of difficult to see. All right, but I know for a fact that LaGuardia is overall at the bottom, you know. So LaGuardia, the blue one, okay, you will see a lot more blue points at the bottom than anything else, and JFK green seems to be kind of in the middle, and I don't know, red, yeah, it's kind of difficult to see. But we have another trick, guys, that we're going to use, okay, in order to find that. Let's use the Geom Smooth. Now, Geom Smooth is great because what it does is it creates some sort of, it's called a rolling average, okay, but it basically tells you the trends of these different data sets. Now, we're not going to get what we're looking for by applying Geom Smooth right now. You see there's even an error, and the reason is because, you know, you haven't really specified anything in it. So this is where you'll see the importance, depending on what you're trying to do, of, you know, putting the aesthetics inside Ggplot. So now, you know, date, average departure delay, and all that is only known by Geom point, but Geom Smooth cannot see it. But if I put this in Ggplot instead, then everything that follows is going to know it. Okay, and you'll see now we're going to get something. Haha. So you see the smooth lines. So the red one here is the, if you want the average over time, the average departure delay over time of flights out of Newark, because it's red. Okay, and you see that it's on top, like throughout it's on top. So this is where you have the higher delays on average daily. Now, when you look at LaGuardia and JFK, you see visually it was kind of hard to see, you know, but at first JFK was worse, you know, LaGuardia was better. Then at some point, you know, in the summer months, LaGuardia better, okay, and towards the end they are kind of the same basically, on average. So that's the geom smooth. It's actually very powerful. Now this is a statistical method called LOES, okay. But you can change the statistical methods if you want, because inside geom smooth you have some parameters that you can change, and these bands there, this is known as uh, the confidence band, okay. uh, you can decide to remove it if you want, or the standard error. So SE for standard error, if you put it false, then you're not going to have any band. You see the bands there, the confidence bands there have disappeared, okay. And if you want to use a linear model, for example, for those of you who know what linear regression is, that's the method you can use. Of course, it's going to give you a straight line instead of a non-linear function. Okay, so now we have straight lines, and this is basically obtained using OLS, ordinary least squares, basically. Okay, but yeah, these are averages. For those of you who don't understand what I just said, don't worry. These are just averages over time. Okay, let me just leave it there. Okay, the method LM. Okay, I'm going to leave it there, but I'm going to comment it out just for you to see that you can do that. Okay, so guys, this is what aesthetic mapping is. Of course, it's really impossible to show you everything, but these are some basics that are really, really solid. Okay, that are really solid, and it will help to use them. Okay. Okay, so I said there were two more things that I was going to show. Of course, I mean, we're taking much more time today than we have in the past. Now, this is the last thing that I want to show you. I want to show you what is called faceting. Okay, and this is another magic with Ggplot 2, because just with one line of code, you can really do a lot. Now, let's assume that, okay, I want to recreate the same plot, but I don't want all these points to be in the same plot, but I want them to be in their own quadrant, okay, or in their own kind of plot, but I still want to plot everything together. Okay, how do I go about this? Well, this is where creating a data set would help us. Let me do that. I'm just going to create a variable for this. This is daily AVG deep delay, departure delay, and here, yeah, I can just write it here. It's going to work. Daily AVG departure delay, because I'm piping it into Ggplot, so this is still going to work anyways. Let me show you to you. Yeah, so same. All right, so now I want everything to be in their own plot. I'm going to show what faceting does. You can pretty much do exactly the same things, all the smoothing stuff. Oh, maybe I can show this to you as well. Okay, let me show this to you. I'm going to call it plot together. All right, and of course this is a variable, so plot together contains that plot that we just made. Okay. But now what I'm going to do is I'm going to add something to it, and I'm doing it like that, so I just want to show you that you can have a Ggplot and then keep adding stuff, even though a part of it is inside a variable. You can use that variable and keep adding. Romina asked a question, can we change the colors in GeoSmooth? Oh yeah, definitely you can. So let me answer Romina's question very quickly. So right now this is what we have, right? But okay, now for this one, all right, so the thing is, because you're using aesthetic mapping, the colors are going to be chosen for you, but you can actually specify the colors that you want, and this is what I want to show you next time. I want to go a little deeper into it, and now that I'm answering this, I was going to mention it later, but let me go ahead and mention it now. These default colors are usually, as you can see, when you're doing aesthetic mapping, they're usually red, green, and blue, and the common colors. But guys, please, if you remember something from this, please remember this. data visualization needs to be, in such a way that you can, impact the most people possible. You see, think about how visualization has impacted us in the COVID-19 times, times in which we are right now, or things like that. So data visualization is basically communicating a message. So if you visualize something that someone does not understand, then you have essentially failed, right? This is why you also need to take people that are colorblind into consideration, which means that, you see, these default colors, colorblind people have an issue with it. Okay, so there are what we call color palettes, which we're going to talk about next time, that are more suited for, color blindness, and of course we're going to talk about that. So Romina, inside Geom Smooth, you can specify the color that you want. But that would be if there is no aesthetic mapping like we are doing right now. So if you want, let me just show it to you quickly, even though I'm going to get back to this code. Let me remove the aesthetic mapping by color, and let me just do this. Yeah, now it's taking a lot more time because it's at, oh no, I think it's just my computer. All right, so you see, this is for everything. All right. Oh yeah, that's actually, thank you very much for your question, right? Once again, Romina. So you see right now, guys, there's only one line. That's the smooth line for all the data. The aesthetic mapping that we had earlier was used by R to know that, okay, I want to do everything for each origin. But now that there's no aesthetic mapping, it just assumes that you want the entire data only. You see how smart it is? And it's very powerful, guys. If you understand it very well, which you're going to practice a lot in your projects, because guys, project coming up, I'm going to talk about it at the end there. But yeah, so this is basically what it is. And in the Geom Smooth, you can specify a color there. Let's say red. Okay. If you do that, oh, it's supposed to plot together now. Okay, yeah. So that's red here for you. Okay. So you can do that. But now, if you do aesthetic mapping, then you will have to do other things. If it is just one line for everybody, you can specify it like that. Okay, then it's not going to mess up your aesthetic mapping. Okay, and actually, if I had specified color red here, all the lines would be red. Okay. Oh no, okay. Okay. I guess it would override the mapping, and it would make one for all. Okay, it would make one for all because it just overrides the mapping. Okay, as you can see. So it really depends on what you want. Okay, it really depends on what you want. If you want to look at the overall average, okay, but you want the points to be colored by origin, you can do that. So, a plot is like art, right? You have to really take your time in order to see the best way to communicate what you want to communicate. Okay, almost 2 hours, guys. Okay, let's do this last thing, the faceting, and then we'll say goodbye. That's a really long stream today. And thank you, guys, because I can see that all of you guys are still here. That's wonderful. I'm glad to see you guys, here still. Okay, so what is it that I wanted to say? I wanted to show you that, okay, I wanted to teach you how to put every single subplot, if you want, in its own little space. So you can use the facet wrap function, or you can use facet grid, which I'm going to show you as well. Okay, so facet wrap means that, okay, you want to separate the plots by something in particular. Okay, so what is that something? That would be origin in our case. So you want the origin, you want 3 plots, each plot is for a specific origin. All right, so this is how you do it. As a function of origin. Okay, that's how you do it, as a function of origin, like this. This is what this tilde here means, basically. Okay, so you want to do it by origin. So you see, just with one line of code, that is it, guys. And we still, because we did the aesthetic mapping by color, you have a different color for each origin again, and the Geom Smooth is the same, and so on and so forth. Okay, and you have all the dates that are repeated here, And that's pretty good. That's actually pretty good. There are more things to do on this actually, but even if I apply a theme, the theme is going to be applied to everything. Let me do theme BW. The theme is going to be applied to everything. You see now it's the black and white background color. Let me make it a little bigger. You can add the labels and a whole lot of things like that. You can even change the titles here if you want to. Okay, so you can really fine tune your plot, but these are like the basic stuff. But if you want the plot to be, exactly like you want to, you will need to specify every little detail. This is very possible. Some people like, to specify every single thing, which is good. I'm not just like that. I'm going to teach you a whole lot of things, but if the defaults, or if I think that what I have is good enough, I think it's okay for me. Okay, guys, that's pretty much what I wanted to show you today. There's more that we're going to do on the on data visualization, but these are very powerful things that I taught you today. We talked about aesthetic mappings. We looked at a few more graphic properties like line type, size. We looked at what else? Alpha for transparency. If you want your graphics to be a little more transparent, and so on and so forth. We looked at all these things. So guys, the sky is the limit at this point. Just do whatever you feel like doing. All right, so once again, I really thank all of you guys who have posted your plots on Slack. I really would love you to make more plots and post them on Slack, especially now that you know all these things. You know how to work with colors and things like that. Guys, do not be shy of using the internet. If there's something that you want to do and I haven't taught you yet, go to the internet, ask me questions on Slack. I'm always willing to help you guys, as you know. But make some beautiful plots, guys, and post them on Slack. Show us what you have done, and try to make as nice plots as you can with some titles, with some even if it's a different data set like Romina did. That's really wonderful. And shout outs to Michael as well, who came up with his own variable. He created a variable called time lost, like, okay, arrival delay multiplied by the number of people that flew. So this is the total time lost, and then he used the bar chart to plot this. That was really beautiful. And we had other plots by other people too, guys. Congratulations.